Hi everyone, this is About Us, and today we will present about the topic applications of differentiation. In this video, there will be introduction, problem statement, problem solution, conclusion, and also reference.
Application of differentiation. So, what is differentiation? Differentiation is process of finding the derivative or rate of change of a function. The rate of change of x with respect to y is given by dy dx if x is a variable and y is another variable. The universal representation of a function's derivative is given by the equation f prime x equal to dy dx where y equal to fx in any function. Techniques of differentiation. First, derivative of constant, linear and power function. Second, derivative of sum and differences. Third, product rule. 4, quotient rule. 5, derivative of trigonometry, exponential and logarithmic function. And the last one is the change rule.
Application of differentiation, related rates, analysis of function 1, analysis of function 2, applied maximum and minimum problems, Rolle's theorem and mean value theorem.
Applied of maximum and minimum problems. What is applied of maximum and minimum problems? Numerous calculation application problems contain functions where you need to identify the maximum or minimum values. The function and its domain will make recommendation regarding the best method to employ when figuring out a maximum or minimum value. First, you need to find the derivative, and then let the derivative equal to 0 and find the value of the variables. Lastly, make a second derivative test. If second derivative is more than 0, it is a minimum value, and if second derivative is less than 0, it is a maximum value.
Adit plans to buy a new aquarium for his growing fish. Find the dimensions of the cube that will have the largest value. The figure below shows a large aquarium in the shape of a cube with a rectangular base in the top. Two of the vertical opposite faces of the cube are square and the height of the cube is 8 meters. A. Given that the surface area of the aquarium is 54 meters square, shows that the capacity of the tank V meters cube is given by V equals to 18x minus 2 over 3x cube. B. Find the maximum value for V, further justifying the fact that it is indeed the maximum value. First, let the length be y. The equation will be 2x power of 2 plus 2y plus xy equals to 54. Solve the equation to get xy. Xy will be 18 minus 2 over 3x power of 2. Then, by using the equation v equals to x power of 2y, factor it to be x bracket of xy. Insert xy that we get before in the equation. Lastly, we will get v equals to 18x minus 2 over 3x power of 3. For b, to find the maximum value of v, we need to find the derivative first. Thus, dv over dx equals to 18 minus 2x power of 2. Let the derivative equal to 0 to find the value of variable s equals to 3. Then, find the second derivative where d power of 2v over dx power of 2 equals to negative 4x. Plus x equals to 3 in the equation. Our second derivative is negative 12, which is less than 0. Indeed, it is a maximum value. Lastly, from 18x minus 2 over 3x power of 3, let s equals to 3 to get the maximum value. Juan Humaira wants to buy a water tank to place behind her house. If it is to contain a given volume, V, what dimensions will require the least amount of water? The figure shows the design of a large water tank in the shape of a cube with a square base and a top. The square base is of length x meters and its height is h meters. It is given that the volume of the tank is 500 meters cubed. A. Show that the surface of 210 meters square is given by A equals to x power of 2 plus 2000 over x. B. Find the value of x which A is stationary. C. Find the minimum value for A, further justifying the fact that it is minimum. For A, let x power of 2h as B. Factor x power of 2h equals to 500 to x bracket xh equals to 500. Then we will get xh equals to 500 over x. From equation A equals to x power of 2 plus xh, let xh equals to 500 over x. Then we will get A equals to x power of 2 plus 2000 over x. For B, differentiate A equals to x power of 2 plus 2000 x power of negative 1. Thus, dA over dx equals to 2x minus 2000 x power of negative 2. To find the value of x which A is stationary, let dA over dx equals to 0. Insert dA over dx equals to 2x minus 2000 x power of negative 2 in the equation and solve. Lastly, we will get x equals to 10 meters. C. From A equals to x power of 2 plus 2000 over x, let x equals to 10. Thus, the minimum value of A is 300 meters square. To justify the fact that it is the minimum, find second derivative where d power of 2 A over dx power of 2 equals to 2 plus 4000 x power of negative 3. Place x equals to 10 in the equation. Then we get 6 which is bigger than 0. Indeed, it is a minimum value.
Applied maximum and minimum problems in real life. Used in space station. A NASA engineer working on the next generation space shuttle studies a function that computes the pressure acting on the shuttle at a given altitude. The absolute maximum of this function represents the pressure that the shuttle must be designed to sustain. Used in chemistry, we have used the maximum of wave function and radial probability distribution function to determine where an electron is more likely to be found in any given orbital. Used in architect, maximum and minimum values are highly demanded in the fields of gay-based MIMO detector. The place and route result using a TSMC 90nm CMOS technology. It is achieved on average 3.6 maximum faster speed and minimum 1.3 minimum faster speed performance compared to the existing partial sorting architect.
In conclusion, differentiation plays an important role in our daily life. By using the right formulas and completing the first and second derivatives, we can easily determine the minimum and maximum values in order to find a solution to a real-life problem. For example, in the business field, finding the maximum and minimum values using differentiation is important to determine the maximum profit in a company, or find the minimum cost, or find the least amount of material to make a particular object, finding the maximum revenue, as well as finding the ticket price in order to maximize total revenue for an event. We can also determine the maximum or minimum value of an area, of an object, or place using differentiation. Hence, we should learn and apply the concept of differentiation in our daily life to help us overcome many types of problems in various situations.